inject their code into the driver and process all the sectors on the disk and remember which ones were encrypted, which ones haven't been, and just continue to encrypt the whole disk until it's done, and then it just continues in regular mode, just doing any encryption and decryption as necessary on reading and writing. So in Windows, the device driver pretty much is implemented like a device driver hooking in Linux through the lower level filter driver, and the in-place on-the-fly disk encryption is a standard feature in Windows. Windows users just would not take, okay, you have to reinstall Windows in order to get disk encryption. They just won't accept that. So, and they shouldn't. So, if you look at this, once the disk is fully encrypted, you're all set and your data is secure more or less. So let's look at what solutions we have on the market that are first for Windows and that are commercial. There's the CompuSec. This is sort of a lesser known, and I don't know really how good it is. I've tried it a few times. I've had some issues with it, but there's two big bonus points. For one, it's free, as in it doesn't cost any money, and there's a Linux version available for you. So it might be worth checking out. Checkpoint has a product that has an interesting part. It's the only full disk encryption solution that's available for Mac OS. So if you're looking at full disk encryption on Mac, this is right now the only way you can go. You can use a solution that comes with Mac OS that encrypts your user directory, but that's a different story. So PGP has one, and I don't know anything interesting to say about this one. SafeNet has a Protect drive, and before the name was SafeNet, it was SafeBoot or something. This is an interesting product to look at. It has a few quirks, and there are some options that I don't know what to make of in terms of like security. But much more interesting is the security finally secure. And it's interesting because its pre-boot authentication environment is actually a Linux-based environment. So what they do is they install a little Linux environment on a newly created partition. This boots, it displays you a little prompt for entering your password or sliding your smart card, and takes the cryptographic material and then actually just then it hooks the Int13, and then it just passes on control to the NT loader to start Windows. So Utimaco Safeguard is, to my knowledge, the first commercial product that's been available to sort of the Microsoft operating systems. And the last one is Windows BitLocker. That's interesting. Windows BitLocker is interesting because it has a specific feature that we'll get to in a moment that no other product has. So the other solutions for Windows open source, I'm sure everyone has heard of TrueCrypt. TrueCrypt is pretty much the reference open source implementation for full disk encryption. And what I personally found is TrueCrypt is a great product, but it has quite a few issues in terms of like internally, but also on the front end, and we'll get to these also. There's another lesser known project that's called Descriptor, and this is actually a project that I've been involved with a little this year, and I'll also get to that in a moment. Then we have the Linux. I've also already said there's the device, or actually there's encrypted file system on, or file systems on encrypted devices. There's the LUKS, the mcrypt. This is the device mapper. LUKS is actually the Linux Unified Key setup or something. It just defines sort of like the specification for the on-disk layout, and dencrypt is sort of the kernel driver glue that makes it all work. We have cryptographic file systems that file systems themselves implement disk encryption, and we don't really want to look at these right now because they're standard file systems, so to say. And then there's the stack file systems that you can use to overlay one file system over another, and the encryption takes place at that level, and neither the file system nor the disk nor anyone else knows about the encryption. So, and that's only for completeness right now. So what are the risks when you use a disk encryption product? How many of you have been to the cold boot yesterday? All right. Everything that was said there is correct, but there's sort of, you have to look at it like, what is your risk? You're really only at risk for this when someone gets a hold of your system that's running, or when someone has been running until very recently, or when it's being able to be made runnable. So when you don't have to supply a cryptographic token in order to boot it up, then you're at risk for a cold boot attack. But you're also at risk to other stuff, like if you have a system that has a network card and the network stack is enabled, you're at risk to being attacked over a network. So full disk encryption does nothing to mitigate that risk. So, but the prime risk, the number one risk, is weak passwords. I know this crowd is a little different than other crowds, so usually people think, okay, 8-character passwords are pretty safe, and it's established that this is sort of the minimum for corporate environments. But if you look at encryption, a password character only gives you about 6 bits of entropy, so randomness. And this is really if you use uppercase, lowercase, digits, and some special characters. If you use less to create your password, then it's less. So if you want to protect a 128 or 256-bit cryptographic key, you would have to use like a 35, 40 character long password. And obviously in a corporate environment, no one will do that. So weak passwords are a significant threat to data being stored on an encrypted hard drive, at least for the software implementations. So the cold boot attacks are listed at number 2 because, as I said, it requires a powered-on computer system. And if you look at the global threat scope, that's really just a minor threat. Coercion is also interesting because if you want to go into the US Customs might ask you to open your computer, provide your password, and they look at whatever data you have. So they can force you to provide your password. They may say, okay, you rejected entry to the United States. They may detain you. They might have ways for you to supply your password. Of course, there are other scenarios where this might be even more threatening, like in criminal environments, they may pose a threat to your health. And you think twice whether your health is more important or your password. So coercion is a risk, and the only way that you can sort of guard yourself against that is sort of by obscurity. If your opponent doesn't even know that you have something to hide, then they won't know what they need to look for. So there's a feature that TrueCrypt implements, which is called hidden operating system, that we'll get to in a minute. And if you have something hidden to a point where you can provide whatever opponent a password that they can open your computer, look at, find nothing suspicious, and if they don't know that there's something more, then they'll be satisfied with that. So there's a few oddities that I found in my work. Number one is TPM support is not TPM support. TPM modules allow you to, or you would expect to use a TPM chip so that you can store your cryptographic key in it. And this is actually the one thing why Windows Vista BitLocker was mentioned, is because it's the only full disk encryption product out there, at least for Windows, that allows you to store your cryptographic key in the TPM. All the other products, they have TPM support, but when you ask them, they're using the TPM to bind the operating system to the TPM chip. So what they do is they boot the operating system, and when you log in, the login function does one more check. It not only checks your password, but it also checks whether the TPM chip is the same TPM chip that was present when the system was installed. So it has no influence on the cryptographic setup. And that was significant realization we've made. We've had several vendors out there, and they all said, yeah, we have TPM support, and when you drill down, they all just sort of go back and say, well, we can work on this. And there's actually one vendor that'll implement the cryptographic key storage on the TPM chip next year. The reason why they don't have it implemented is also fairly trivial, because TPM chips are vendor-specific, proprietary devices pretty much, and they you need to know what protocol to talk to each model and make of a TPM chip, and they don't want to do that. So they want to, you know, if they say we need TPM support, they want a TPM support for everybody, and there's a well-defined interface on Windows, Windows DLL, that every TPM manufacturer adheres to. So they just take the easy implementation route and implement the wrong thing. Another thing we noticed was multi-disk setup, and I'm not talking about RAID here. So we're talking about a C drive and a D drive. You want to encrypt both disks, and pretty much all the products support this, but pretty much all the products fail when you actually have a disk failing. So there's pretty much not a single product out there that allows you to run a system with two disks. And you know, I'm talking about internal disks. I'm not talking about USB drives or anything. So you got to expect some failure at some point from one of the disks, and all these products fail. And when such a failure occurs, all the products have to be deinstalled, which means decrypting your encrypted system, which means removing the software, which means reinstalling, which means re-encrypting all drives. And that's just the major flaw when you look at, you know, 20,000 systems that have multiple disks, and you want to install a full disk encryption software on there. RAID is a sort of different story, because RAID sort of abstracts the multiple disk setup to the cryptographic component. So if your product that you choose has RAID support, then very likely you'll be okay with RAID failures. So now we go into a little segment that focuses on open source, TrueCrypt. It has unique cryptographic features. I've already mentioned hidden operating system support. It's also pretty much the only full disk encryption product out there that sort of has its on-disk layout set up so that you cannot deduce that there is encrypted data on it. So if you don't have anything pointing to that there is data on it, you won't know that there is data on it. You won't be able to prove it. It's multi-platform compatible, runs on Linux and OS X and whatever else. But it's unsuitable for most enterprise environments because there's no key management. TrueCrypt, you can specify a password, encrypt your hard disk, fine, but when you're an admin, you need recoverability, and you cannot do that with TrueCrypt just yet. You also are not likely to be able to do that with TrueCrypt because the TrueCrypt specifications don't provide for that. There's no user management, so you have a single password for your encrypted disk. If you have multiple users using it, you need to use the same password and give it to both users.